Today, we're in for a treat because we're finding the derivatives of the four trig functions we have yet to work with, right? That being cosecant, secant, cotangent, and tangent. And these are actually really easy to do, and I'm very excited about today's video. So let's just get into it, right? We want to find the derivative with respect to x of, let's do cosecant of x first, right? Now, how do we do this, right? All we know are the derivatives of sine and cosine at this point, right? But it turns out that's all we need to know, right? Because cosecant of x, we know, is the exact same thing as 1 over the sine of x, which is the same thing as saying sine of x to the negative 1 power. And we could take the chain rule of that, and we know how to do chain rule, so let's do it, right? So we are going to do the derivative with respect to x of cosecant of x, and that is going to be equal to, so chain rule, we're going to move that power to the front, that negative 1, and we're going to lower the power by 1, that's negative 2, and then we got to multiply by the derivative of the inside, and we know that the derivative of sine of x is cosine x. And now this can be rewritten as a fraction, so let's do that, right? Because we always want to simplify our answer. So we have cosine of x, and it's going to be negative because we have that negative 1 times the sine of x. And then we have sine of x to the negative 2 power, so that just means that it's going to go in the denominator. And we're going to square that. And this can be written as the product of two fractions, right? So we're going to have negative cosine of x times the sine of x. Negative cosine of x divided by sine of x, sorry. And then that's going to be times 1 over sine of x. And we're done. But again, we're going to simplify. We know from pre-calc that negative cosine over sine is the same thing as negative cotangent. So we got negative cotangent x. And just as we said in the beginning, 1 over sine of x is cosecant of x. And that's it. We found our derivative. This is our answer, negative cotangent times cosecant of x. So now let's do secant x, right? Let's get into that. So we have the derivative of secant of x. Again, this can be rewritten just like the last one. This can be the same thing as 1 over cosine of x, right? And like the last one, this can be the same thing as cosine of x to the negative 1 power. And we can do the chain rule on that, so that's what we're going to do. The derivative with respect to x of secant of x is equal to, okay, let's bring that power to the front, negative 1 times cosine of x. Lower that power by 1. Multiply by the derivative of the inside. We know that that is negative sine of x. Now, again, let's write this as a fraction, right? So we got the negatives are going to cancel each other out from both terms, so we could just say that it's positive now. We have sine of x over cosine of x squared. Let's rewrite this as a product of two fractions, right? We got sine of x. We're just manipulating our answer to be something easier for us to read. So this is times 1 over cosine x. And from pre-calc, we know that sine of x over cosine x is equal to tangent. And we know that 1 over cosine is equal to secant. Sorry, I was about to say cosecant. So 1 over cosine is secant of x, and that's our answer. Tangent x times secant x. So now we're just left with cotangent and tangent. So let's do those. These ones, we're not going to be using the, the chain rule. We're going to be using the quotient rule because cotangent of x can be rewritten as cosine x over sine of x. And since we know the derivatives of those, this is where we can do our quotient rule, right? So let's start doing that. The derivative with respect to x of cotangent x, quotient is equal to quotient rule. So derivative of the numerator, that's sine of x, times the denominator, sine of x, minus the numerator, cosine of x, times the derivative of the denominator, so that is going to be cosine of x, all over our denominator squared, so that is sine squared x. Now, let's multiply out our everything we have in our numerator, okay? Let's see, we got negative sine squared x, and then we get minus cosine squared x. Now, I don't know about you, but that numerator looks extremely familiar to me because it's actually a trig identity. Wow, isn't it? Who would have thought that pre-calculus is going to be helpful in calculus? And from pre-calc, we know that negative sine squared x minus cosine squared x is the same thing as saying -1. And all of that is over sine squared x, which can be rewritten as the negative, as the negative cosecant squared x. Look at that. We just found the derivative of cotangent, and all we have left is tangent. So let's do that. And you're going to see that it is actually very similar to our cotangent, right? So the derivative with respect to x of tangent of x, this can be rewritten as, as the sine of x divided by cosine of x. And let's start doing our quotient rule. All right, so we got the derivative with respect to x of tangent x is equal to, okay, quotient rule, again, the derivative of the numerator, that we know is cosine of x, times the denominator, so cosine x, minus the numerator, sine of x, times the derivative of the denominator, we know that that is negative sine of x. All of this is over cosine squared x, because it's just the denominator squared. We're going to multiply out our numerator like we just did before, so that is cosine squared x, and then negative sine x times negative sine x is positive, so we get positive sine squared x. That's a difference. Before we had minus signs. And then all over cosine squared x. And again, from pre-calc, we know that cosine squared x plus sine squared x is just equal to 1. And then we have over cosine squared x, which can be rewritten as secant squared x. And with that, we found super easily the derivatives of cosecant, secant, cotangent, and tangent.